let's walk through example 18.14, which is going to show us some of the rules when it comes to finding integrals or the areas underneath functions between two x values. For instance, this right here, this integral from 0 to 5 of the function x tells us that we're going to take the function x, and x is going to travel from 0 to 5, and this integral symbol finds us the area underneath the function x between x is equal to 0 and x is equal to 5. So effectively, this integral symbol right now, as we understand it, just gives us the area underneath the function between 2 points. Now let's work on A. I want to find the integral between 0 and 5 of x cubed minus x squared. I can, by linearity, distribute the integral to the x cubed function and to the x squared function separately. And remember, every time you write down an integral sign, you also tell yourself with respect to which variable. Just like when you write a derivative, you tell yourself with respect to which variable. So we aren't worried so far at computing these values. These are actually given to us in the problem statement. So the area underneath the cubic function between 0 and 5 is 156.25. In fact, let me just color code these. And we want to subtract the area underneath the x squared function between 0 and 5. So we just find the difference between these two values, and we find 114.58. All right, let's do the next one. The integral from 0 to 5 of x squared plus 5. Again, by linearity, we can differentiate x squared and add to it the integral of 5. So the integral between 0 and 5 of x squared, we've actually already used that. This is in blue. We get 41.67. And now I need to add the integral underneath 5 between 0 and 5, which that is not given to us. So we're going to have to figure this out for ourselves. But fortunately, it's not that difficult. If the function is always equal to 5, that's what we have here. Just the constant 5. And we want to find the area underneath that between 0 and 5. This is just a rectangle with a base of 5 and a height of 5. So it should be 25. And that's the area underneath that function. So adding these two together, we get 66.67. All right, now for the integral between 0 and 9 of x squared. Let's see what information in the problem we can use. I can use this information along with this information. So effectively, if I can draw the picture, we've got the x squared function between 0 and 9. And what we can use is I can integrate this function up until 5 and find this area here. And then I can just add to that the integral between 5 and 9 to get the rest of the area. So we can write this as the integral between 0 and 5 of x squared plus the integral between 5 and 9 of x squared. By using the information that we have, this is 41.67 plus 201.33 for a final answer of 243. All right, now our last question, the integral between 5 and 0 of x. So integration, unlike what you would usually think of when it comes to areas, actually has a direction or a sign. If you have a function and you integrate from a to b, that's actually the opposite of integrating from b to a. So a direction is important. So I can find the integral between 5 and 0 by taking the negative of the integral between 0 and 5. And this hopefully is given to us. Yes, the integral between 0 and 5 of x is just 12.5. So the integral between 5 and 0 is minus 12.5.